Welcome to Spokane. Is everyone having a nice time walking along the river? So beautiful. Oh, here we go. Great. So I know we're all here because we know we need housing, and especially this group working on affordable housing, so I'm not going to spend a lot of time on it, but I think it's the thing that really drives us. It's the thing that's like we know we have to do. We have to scale how we build housing, we have to build more housing, in kind of any way possible. And we have a huge innovation lean. We believe that the future of housing and how we build is coming, but we also know that we're in the regulatory environments and we're with the materials and the processes we have today, with the performas we have today, so we really are looking to build housing in any means possible. Our company is, got many companies in this company, if you like Ted Lasso. We've got construction technology, which is our innovation and prefabrication side. We've got our sustainable development, where we do everything from supporting developer clients with their property acquisition, feasibility, pre-development, design and architecture, architecture in-house, design management otherwise, and general contracting. And then we've run real estate funds, like fairly small format real estate funds, to help projects get that last little bit of equity or debt to start moving, especially when they're tight. We build housing under 4 stories, up to 6 stories really, but we love that 4 stories and under, urban infill. Our bread and butter over the last 10 years has been townhouses, and we're moving now into cottage clusters and apartments. So I like to just really reiterate that because people don't know they can hire us sometimes, and we definitely can be hired to build housing in Oregon and Washington under 6 stories. If you're doing it, let us know. We want to help you out. We build, like I just said, any way possible. The bulk of our history is in stick frame, on-site construction, but we are doing more and more with either panelized construction and our own building system, which is in mass timber, where we're doing prefabricated mass timber structures. And we know it has to fit your performa. So as we head down towards deep sustainability, carbon negative, net zero, as much as we can get into the performa, we know that the more that we systematize and the more that we create prefabrication, the more we're going to be able to do that every single time. When we work with clients, we really work on making sure that the costs are controlled while we hit those sustainability goals. And here's the fun part and why we're here at this mass timber. Does everyone know what mass timber is? Who doesn't? Maybe if you don't know what mass timber is, I can start from the top of mass timber. Okay, great. You know what? Other people are with you, but everyone's shy, So mass timber is a structural building material. We've got a press with Todd in Spokane Valley, about 20 minutes from here. They're taking 2x6s, just regular 2x6s, planing them, making them nice, gluing them up together. Everyone's probably worked with a glue lamp before, where you see stacked. The cross-laminated timber is in a panel that's maybe 12 feet by 60 feet wide, and it's laid down flat and then cross-laid on top of each other. So it's a sheet of plywood, but just made with 2x6s. It is an incredible structural material. It has got a lot of extra rigidity and structural properties. It can be precision engineered and can be cut with a CNC machine. So we're getting tolerances and prefabrication that you don't get in wood. And if anyone's ever tried to take a 2x material and turn it into some kind of system, you realize really quickly that a 1/4 inch isn't enough tolerance. That there's like all this wonk and wobble in every one of those sticks. So we're really using this in housing is about getting to that precision performance. I'm gonna let other folks talk about larger buildings. I think building in this low-rise space, there's this kind of industry thought that you can't use mass timber for low-rise because it'll never pencil. And it's what we are fighting so hard for. 8 stories and over, everyone's like, oh yeah, tall wood, mass timber, but we're like, and also carbon negative housing at the 1, 2, 3, 4 story level. And in order to do that, we need a building system. We need to stop building everything from scratch. In the history of manufacturing and housing, we like to draw up a floor plan and then figure out how to manufacture it. And we're kind of going the other way. We're like, we need manufacturable components, manufacturable designs that then really lets you use the leverage of manufacturing. Those even flow throughput is based on the same components going through the line and even timing. To get to housing, that maybe one day we'll even have varied floor plans and installations. That happens in Japan and Sweden and other places. It's a dream here in the US. Our regulatory environment is in the way, but we can still create building systems that are more manufacturable. while we're doing that, we can work on sustainability. Our flagship product was a utility wall, and it still is, and we put it in our integrated kit buildings. You know, we built a lot of houses, and we could go through all the daily logs and tell you that most of the time, something that cost us extra money and rework or time later was in the mechanical, electrical, plumbing zone, and especially rework. The number of times someone drilled through a water line installing a cabinet. Like, and we're not special. My friend just bought a house. It just happened to her. She's like, I can't believe someone drilled through a water line. And I was like, you wouldn't believe how common that is. Like, it's so common. But we can protect for that with systems. We can also save a lot of time on install, optimize for performance, really trying to hack that labor problem on site. So today we're selling. This is kind of fun. There's no prompt ahead of me, so I have to look. I built these slides this morning. In our building system kits, these are projects we have examples of on the ground. We've got townhomes, we've got cottages, both two-story units heading to Portland and one-story units heading to Bainbridge Island, Washington, and we're working on an apartment building. So all of these based on the same component parts, so we can really start to leverage that system. We got a team here up in the front. If you have questions afterwards, feel free to talk to Darren or Genevieve. And if you want to take a look at what we're doing, we do have a model home in Spokane, at Spokane Valley, next to Mercer Mass Timber, and we can try to get out there tomorrow. So we do prefabrication because it's faster. You guys doing a time check on me? Probably someone should, huh? Okay, cool. So moderate yourselves, we can do it. We do it because it's faster. Even in these low numbers of prefabrication that we're doing now, 9 here, 7 there, we know we're saving 50% time, and we're not even fully optimized for it. And time, of course, is like getting people indoors faster. It's also how fast we get to revenue, whether it's rental revenue or sales revenue, which can really help performers out. All these units are optimized for layout. This is where like the rubber meets the road. Everyone's like, this is such a great idea. What do you mean my bathroom needs to be over there? Every single, like, architects, love you, every single time. We have to optimize for the repeatability and then work around the edges where the design can be flexible. And this is how we get to optimized layouts. 3 more slides here. One is we've got DOE grants for advanced research projects, working with other partnerships, trying to get to carbon negative and circular home. So that means not just like the building embodied energy and then also the operational performance is carbon negative, but then those parts and pieces can be used a really long time later. And what is the structural value of mass timber in 100 years or even longer? And that is an awesome project funded by the Department of Energy. The second phase of it we're working on now, and we're hoping to get to dispersed delivery systems for off-site manufacturing. Kind of a crazy idea, but how do you go more lightweight while we get units on site? So you can kind of follow us along. That'll be 2025 for us, and we'll let you know how it goes. And we're not alone in this, but the U.S. Forest Service is really helpful with wood innovation grants and trying to get wood products to be more and more used, especially wood products that can replace steel and concrete, not only for its carbon benefit, but for its the national interest of using forest. And we love those wood innovation grants to help us along the way. This is a little teaser. City of Seattle launched a program to figure out what is going to help. Originally, the thought was Puget Sound build more mass timber. And they created the Washington Mass Timber Alliance. I'm on the board of that. I think we're going to have a website live like in the next couple of weeks, maybe, if all of us can take a break from our day jobs. What it turned into pretty quickly, and I think the reason that it's important, I want to make sure I mention it here, is an innovation cluster supporter. So really helping the entire state of Washington accelerate the use of mass timber, building off of the work that's been done for the last 15 years, and figure out how do we take this little nascent pre-industry and help it grow through projects, education, accelerators, whatever needs to happen. So keep an eye out for that. And I'm going to pause here because I definitely have been talking for 7 minutes and pass the mic to Megan. But thanks for listening and happy to answer questions later.
All right, I'm also going to make a good effort to try and keep this on time because some of you may have heard about this project before. We've been telling everyone about it at every chance we get. So I'll try not to repeat too much information. But for those of you that don't know, Heartwood is a workforce housing project in Seattle, right on the boundary of Capitol Hill and Central District. It targets that sort of missing middle income, 60 to 100% AMI. So it's not traditional affordable housing, but also very importantly, it is 8 stories of mass timber, and it is the first as of right permitted in this new Type 4C building code, which I'll explain a little bit more. Some background on Atelier Jones. I think I didn't do my actual introduction part. I'm Megan Doring. I'm an architect with Atelier Jones. We're based in Seattle, Washington, and we've been involved with mass timber since its earliest stages in the US. So that started with building one of the first CLT houses in the US in 2015, getting involved in the International Code Committee's Tallwood Building Committee to rewrite those codes so that in 2021 we could make tall timber a possibility, and then working further through more fire tests to revise those codes for 2024 to make it even easier and expose more timber in those buildings. So just a high-level summary of what these codes are. We created 3 new building types. Type 4 used to be the heavy timber area, so now that's Type 4 HT, and then we have these 3 new types, which are Type 4 C, B, and A. C being the 8-story, that's your least restrictive. You can expose all your timber, you can look at all of it. Type 4B is that sweet spot in the middle, that 12-story model, where you have to cover up just a little bit of your timber. And then Type 4A, which is up to 18 stories, but you have to cover all your timber with gypsum wallboard. So how does this apply to Heartwood? So Heartwood is located, like I said, at that boundary of the Capitol Hill and the Central District. It's on a shared site with the existing Helen V apartments, which are an affordable building that's owned and operated by Community Roots Housing, which is a long-standing nonprofit in the Capitol Hill area that you guys might be familiar with. And the challenge with this site, so it was building on a site with an already active building that people are living in. We have power lines, we have a sidewalk that has to remain open, and that's a point accessed building, which means we have to keep all of the entrances accessible at all times. And we had, of course, trees and all of those other things. With urban infill, there's all of these difficulties, and we had no laydown area on this site. And that's really what made mass timber an interest to this project, that we could do that just in time delivery and get everything straight from the truck into erection. So just some background on the building. There was always a focus on this building on balancing and working together with efficiency to get as many units and as many housing units in this project as possible, but also it needed to create a community with this existing building. This would end up being a mixed income community between this already affordable building and this new sort of missing middle income workforce housing project. So we did that by keeping those upper floors really, really simple and really repeatable. These are studio and 1-bedroom units, so they're very efficient pricing-wise to build. We all know that that's what normally makes projects pencil. But we focused all of our design efforts on that ground floor. So we're carving back spaces to create those shared entries, shared amenities that are serving both buildings, both populations, and this was input from those existing residents that helped shape these spaces. So we're being very intentional with where we're putting our design and where we're being very, very efficient. But to give you a little backup and explain how this project came to be, Heartwood project received a Wood Innovation Grant in 2019 to support the pre-development phase and the feasibility studies for this project. And what really made it work and made mass timber interesting for this project was the fact that we were able to get those additional 3 stories above what we could otherwise build and up to the maximum allowable in the zoning because we went with mass timber. There were some sensitive soils on this site, so we couldn't really go in the ground. We needed to keep a really lightweight, shallow foundation, and mass timber allowed us to get that density and that additional height without disturbing those soils. So this is a slab-on-grade foundation with a little bit of mat under the elevators, but otherwise it's very minimal concrete. And I can give you some high-level summaries on the capital stack for this project. This was not my area of expertise. This was AP Hurd with Skipstone that really did all the wizardry on this. So this is this is not a publicly funded project, so there's no LIHTC here. It received a conventional loan with 2021 interest rates and had a little bit of private equity, but otherwise is traditionally funded. And part of that funding and making that funding work is the longer predicted lifespan for this building over a traditional stick frame building. So they, I think, landed on an assumption of 150 years, which is probably still conservative given that there are heavy timber and original mass timber buildings from the 19th century still going strong that people are living in. A little summary on the cost as well. So we had a 2021 construction GMP at $225,000 per unit, and this project, like any project, did run into some conventional construction cost impacts, those being the Teamster strike for the concrete that hit all of Seattle right at the time we were trying to pour concrete, and the typical sort of supply chain issues that I think everyone has been dealing with for the last couple of years here. But the mass timber itself was smooth and on schedule, and that install went at about a floor every week and a half, and that's including the seismic core that went up at the same time. But working with mass timber, we have to consider certain things in feasibility that you otherwise wouldn't. So you're front-loading some of your design effort. And an example of that was in this project, we had to study in detail the reflected ceiling plans of the units when we were still in pre-development because of some of the quirks of the tall timber code. Concealed spaces add a lot of cost because you have to just treat them a little more specially and line them with non-combustible material. So we considered where we routed every single service and material at the pre-development stage and really figured out where things were going. And a lot of this comes with when you're establishing this novel new system, you have to front load some of that effort. And prefabrication is certainly a part of that. You're thinking about things earlier on. But this new system is based around this all wood joint. So your structure for these Type 4C buildings needs to be 2-hour rated, and this is a 2-hour rated joint that's all wood with no steel connectors. There's a few screws in there, but you're not doing steel hangers or anything like that. So that saved us a lot of cost in the steel package. I think it came to like $5 a square foot or something like that, a significant cost in the steel package while maintaining that 2-hour connection, and this is approved by the city of Seattle and works for the Type 4B and the Type 4C buildings. But the system that this is based off of, this post and beam sort of column loaded system as opposed to a bearing wall, means that we have really flexible grids. We can go from 12 feet to 18 feet really easily, and that means we can adapt to the site really easily. So Heartwood has grids that are sort of look like they're all over the place, but it's just so we could squeeze in as many units as possible. But it also means that in the future, none of those walls are bearing. You can take them all down. This can become 3-bedroom condos. It can become whatever it needs to be 100 years from now, because the facade can come off. That's not load bearing either. So the long-term adaptability is thought into this building from the very start. But all of that long-term adaptability, we also have to think about a lot of things earlier on when we're trying to get these dense units in here. So we talked to a lot of our consultants and got our entire team on board really early in the process. So in the early stages, we were talking to obviously structural, but also fire protection engineers, to our acoustic engineers, a lot of these small things that needed to have the code language interpreted through the city of Seattle. So we're not asking for any exceptions, but we're needing a lot of things defined for the first time. That's not to say that you still want to get those engineers involved early in any mass timber project because you're prefabricating. We're cutting every hole in the factory that's larger than 4 inches. So we need to know where every single pipe's going. But that early design and that early feedback from our consultants meant that we were able to expose more timber in some of these secondary spaces. So our corridors are completely exposed except for a sprinkler line, because we were able to tuck away our services in other areas. We were able to get exposed timber on our egress stairs. So those are not special feature stairs. Those are the regular exit stairs. And using that mass plywood panel meant that those stairs went up at the same time and the same pace as the rest of the building. We didn't need secondary construction access stairs. They helped in so many ways, but it also helps the overall effect of the building without adding extra cost. So we're getting all of this warmth and this exposed timber just with the efficiency of the structure and the basics of the building. But with exposing all of that timber, we have to be really cognizant about where we're getting that timber from. And Atelier Jones has always focused on like Cascadia wood basket, where we know our forestry laws are very strong. We trust them. We have relationships with our suppliers. We know the forest they're pulling their wood from because they know the forest they're pulling their wood from, and we visited a lot of them. It has the secondary benefit of reducing our transportation cost and the carbon of our transportation as well. So you can see where everything for this building was sourced within about 500 miles of Seattle. But how does that work into the carbon? So we completed a life cycle analysis with the University of Washington, where we compared Heartwood to an equivalent concrete building. So if you were to build an 8-story concrete building, and that's where we found, and we can confidently now say, that the structure of this building is net negative. So there's more carbon stored in that timber than is expended to create the concrete, the steel, to transport it to site, to put it up. But then we also took that even further, and we studied the end of life of this building. So if you were to take this building down, reuse the parts to build another building, some of it becomes OSB and particle board, and several cycles of rebuilding, recycling, creating new products. Even after all of it ends up in a landfill 300 years from now, 88% of that carbon remains stored forever. So we can say that we're capturing all of that, and that is helping that overall net negative carbon footprint. We don't have to worry that all of that's eventually being released back. And we can also, through more recent research, say that these are probably conservative assumptions. You're probably getting a longer lifespan than 100 years, and we're probably reusing more of that timber than we assumed in this study. I think we assumed 10% waste every time you're reusing that product, and our recent research is showing that we're getting nearly all of it into reuse because of the way we're doing our joint connections. There's not steel kerf plates or things that we have to take out of these. It's an all wood connection. You can use more of that wood. So where is this going in the long term? We're currently working on replication, on doing this again at scale. We all know that our housing crisis is a scale problem. We need big solutions, and for our carbon and climate change issues, as well as our housing. So we're working on doing this and finding those efficiencies, because this was a first-time sort of semi-novel system. We want to find how we can standardize this and replicate it and make it work, and we're excited to see where that goes. All right, with that, I will pass it off.
Okay, thank you, Megan Beck. I'm Todd Bayreuther. My role is at Mercer Mass Timber, which is a factory in the valley here, Spokane Valley, is as the product director. So in that, I'm focused on bringing new products to market, and that's the materials, but also this is a presentation about components and assemblies that help answer the question that we were tasked with here, which was mass timber triple bottom line, is it real? I hope so, otherwise I need a new career. But if not, it's because we're not doing it right. And in this, what I want to share with you a little bit is more of the industrialist side of it. I come from a design engineering background, but right now we think of mass timber on big projects like Heartwood, where it's a typical design bid build. So we have obviously our project teams that service those things. We have the manufacturing, and then we have the construction that installs and the buildings. What I want to say in this small little diagram here is the not doing it right part on the housing side. I spent all my time trying to move into the housing industrial markets, which we designed that factory for in Katera back in 2016. Just a little history on that factory. It makes it a little different than other mass timber factories. It was designed only to make floor plates for Katerra 3-story garden walk-up. So it was a scale problem for housing. Over time, through acquisition and so forth, it shifted to now 90% of our business is working with large commercial office buildings and these big projects. So this is an important part of the story, yet we need to turn it back on to help the housing piece. So in that, it's really about manufacturing, and in the state of Washington, it's about taking a primary factory and supplying the secondary assembly facilities, the advanced manufacturing that's needed to scale this problem. So I'll get a little deeper into that. I'm going to go through some abstract diagrams very quickly just to talk about the different building typologies. What Megan just presented on was their typical post and beam. These are the big projects that are really sitting at above 6 or 8 stories. You have 1 hour fire ratings where you might have that 15-foot span. You have longer spans. If you can get a chance to go visit Catalyst, our first building out of that factory, which is a 5-story commercial building here. Rib panels allow us to get up to 30 or so feet. There's 2-hour fire ratings where we start to see really big members, such as buildings in Milwaukee where you have 3-foot by 3-foot columns. This is where the industry is going. A lot of that's about fire protection, char. And then you see less of this in the U.S., but as we get into residential, Europeans are, it's very typical to see load-bearing walls. We don't do this a lot in our area. We're in seismic zones. This is not a real practical solution unless we're creative about this. But it's important that we talk about the application of housing, the post and beam with cold form steel infill, the post and panel like Brock Commons, if you're familiar up in Vancouver, that was a residential tight grid, non-load-bearing cold form steel infill. Steel, it had all been encapsulated, but steel hybrids are a big topic right now, and that also can mean load-bearing cold form steel. All these are on the table, and all are relevant from 1 to 12, 18 stories. Now this diagram here, this for structural engineers, this is more of the the utilization of where we can apply this. When we're looking at all those different systems and the materials we're making, we do all these obviously structural engineering checks. Is it strong enough at service condition, at fire condition, 1 hour, 2 hour fire rate? And what I want to emphasize on the bottom here is those bottom bars. If you dig deep into this, it's about the service ability, the vibration, the deflection, the so forth. And in those big projects where we have the simple span, now let's get into the product side of it. We're doing single spans, we're putting a lot of concrete and so forth on it to make sure that we meet all those performance requirements. So it's not about what's the least amount of material we can use. It's not an engineering problem in the sense of what's the most efficient, lightest weight building. It's what's the appropriate amount. So that starts to get into our Washington story of here are our markets, obviously in the Pacific Northwest. This is how we land these kind of facilities in the Pacific Northwest. The answer is, where do you put one of these? You put it in Longview, Washington, or Spokane is what we came to the conclusion. Obviously, Oregon's going to be, along the I-5 corridor is relevant also. But it's Spokane was our solution because of the diversity of the different species. So this presentation isn't about the wildfire side and so forth, but it's all part of the story that how do we utilize those species? How do we tie into our fiber basket here? Reinforce our rural economies while we're doing this and serving all markets across the state and creating those jobs. And then an important part of the story that I want to emphasize on this is as we look at the market diffusion, those lower blue bars there are the way we're doing it now. So this is the relevancy of how we grow this. Yes, we need to do the big buildings, but when we look at our housing needs, over 90% of that's going to be low-rise construction. How do we fill that gap between low-rise and the mid-rise that was presented earlier? And so it's really about the building systems and how we certify, manufacture, and scale those. And I'll put real numbers on these. The dark blue bars or the light blue bars are the way we're doing it now. And that's why they're competitive in the mid-rise, the commercial, so forth, because it's less efficient through a factory like we have out in the valley. We're putting about half of the volume through what the batch process that we could, and that works if the market can carry it. Housing can't carry $1,800 a cubic meter. It has to be below $1,200. Therefore, we have to design the processes and the buildings differently than we do the big buildings. So I'm going to go very quickly through this, but as we look at our fiber shed, it's also about utilization. Beck, I agree and disagree with the slapping 2x4s together. That's how we do it now. That's not how we're going to do it in the near future. We always do that. But my point there is that it's that integrated. We look at what the opportunities are. Just bidding factories against each other is only going to save you a couple percentage points. To dig deep, you have to go all the way up the supply chain and start to say, look at the efficiencies of our fiber, how we grade them, the technical side of that. Most importantly is this one. If these factories make one panel at a time, that's that $1,800 a cubic meter. If we can start to make thicker members, and more importantly, make multiple panels at a time, and then have higher design efficiency, that's where we realize the big savings. And I challenge anyone in a mature product. The reason I get excited about my job is I can't think of another product, steel, lumber, so forth, where you could pull out almost 50% of the cost just by being a better designer, architect, engineer, and then importantly, the process engineering. So this is what a panel looks like after we do, this is a 5-ply. That's the additive piece. Quickly get into the fun part in the design is the subtractive piece. When I say efficiency on the panel, it doesn't mean you have to take a 12-foot by 60-foot panel that we make and divide it up perfectly, or a 10-foot by 48 panel that somebody else makes. We need to use the CNC machines to make our processes faster. If it means we're getting rid of measuring on site, we're making grooves so that we land, floor or sill plates, so forth, in the material. Let's take that time and do that, because that's the automation piece. And we can make buildings like this that aren't cost effective. They might be more relevant for high-end single family, but we can do ADUs, we can do townhomes, and then we obviously can now start to build into cottages and other multifamily flats and so forth. But what I want to really quickly share, and we're doing that, and Beck and company have been great partners. If you come see the prototype at the factory, this is it. This is our first time in our factory doing assembly level that we want other partners to, we need 10 of those factories across the state to keep up with the scale of these CLT factories. So, of course, we can supply everything from this factory, but more importantly, can we start to make systems that also flat pack out the components to other factories? Now, this would show across the entire U.S. Let's do 10 of these across Washington, Everett, Tri-Cities, so forth, and get closer to the markets, and so that we can do that. To do that, we have to come up with new systems that do start to utilize those panels better. So the takeaway from this is you don't have to do solid mass timber across 160 by 12-foot panels. You can make lots of components. And as we're going through and getting certification on the different types of systems, we can use the CLT for studs, for posts, for floor plates, so forth. This is new to the market. I should have recognized this is Forest Service research right now, but this is what we're bringing to market, and we want to work with lots of partners that will work with us. And I often get the question, well, I can stick frame that for cheaper and so forth. Please do. More of it. We're not anywhere near, obviously, the 60,000 homes we need a year in Washington per the Lieutenant Governor's report. So if you can do that on a marshmallows, please do. But we're trying to find other ways we can scale. The factory out there, as one example, can do 5,000 homes of components if we have people that can assemble them quickly enough, new labor forces, so forth. So this is what it looks like. This is just some images of the testing and prototyping we're doing down at Washington State University. It's always been part of the story. These are pictures from Europe. We're not making this up. This is done for other reasons where performance-based design is used for energy, for structure. And this is a picture from Finland. The last ones were from Switzerland. We think there are other ways where we can start to use this now. There's 4 components on the right replacing 50 components on the left. We're not replacing labor. It's an and. We're doing different types of creative class labor. This is what these details can look like in the lab. It looks different, but what we're doing is showing equivalency to what we already know in terms of stick framing. That's why we use plywood, we use rocking walls, and so forth. And so it's a fun space, but you have to prove everything. You have to prove all the way down to how the screws behave, so forth. And we have the resources in the state. That's why this factory is in Spokane, so we can be near WSU and leverage those resources. But we also have the resources in Seattle. I'm a Husky, and we have the designers we have the engineers, we have the industrialists that know how to make things the size of a building and fly them through the air. So in that confidence, then you can see the result of what our proposal is with our partners on a housing relevant system. So with that, I'll take a breath and conclude though by saying, to solve the housing, to address the housing crisis, we need to address industrial. So interestingly enough, in our space, it's also how do we make these factories, distribution center, data centers that not only allow us to scale the product, that helps to share the costs and drive down housing, and also allows us to make these buildings. So, okay, thank you.
Thank you so much for that great presentation. There's a question in the app, and please use your app if you have questions, or we can take questions up here. On the Heartwood model, if the project had less density, other unit types, 1 bedroom, 2 bedrooms versus the 1 bedroom studios, or was shorter, would the cost efficiencies and carbon savings be comparable, or what would some of the trade-offs be?
I can only answer this very generally because I was not super involved in the pro forma financing side of this, but because this was a traditionally financed project that was financed as if it's market rate, it relied on that density of units to make it work. So we needed those studios and 1 bedrooms and that level of density. That's not to say you can't make larger scale units work with this same system of mass timber. We've been doing a lot of studies on that, and I can confidently say it does work. And we've been studying it for affordable housing specifically. So it's possible. We just keep getting stuck in the pipeline, as I think everyone else does.
Okay, there's another question. Great. So exciting. Thank you. In terms of amount of time spent detailing, how would a mass timber building like the Heartwood compare to a building with concrete or steel structural elements?
I can say that the overall amount of time is probably similar. You're just pushing that forward in your project timeline when you prefabricate and pre-manufacture pieces. So your design time is being pushed forward, and then you also have to account for your procurement cost moving forward. You're putting down those deposits early. So it's not that it's costing more design or costing more in material, it's that your schedule changes and your financing schedule changes.
Do you want to comment any more on that?
I think that's the answer. When we do prefabricated components, we design more upfront. I think in general, to make construction more efficient, we're bringing more and more into the pre-construction phases. Yeah.
But that's inside. I mean, talk more about kind of what's happening in the production facility.
I think another message I hope you take away is that, when Megan concluded with, now we're trying to scale, yes, on that one project, you can compare just what that one project to a custom project, but that's kind of not the intent. The intent is both what I was presenting, Beck and Megan were presenting, was how do we do these replicated designs and get these approval of systems and components and details and so forth, so that we're not doing that every time. That's how we scale it. Otherwise, yes, if you're doing a one-off design bid build project, it's just different. It's a whole different. It's like on a concrete building, you might be, deferring a bunch of that detailing or the steel building to a prefabrication. You're going to review shop drawing and so forth. That's the same thing we do in the custom mass timber spaces. I think our proposal is let's do that, but then do it 100 times. Yeah.
And so to that point, I guess there's a question about the hybrid system available. When will the hybrid system be available at scale? What's the timeline? And will there be code coordination with local municipalities?
Well, I'll take that. I guess I didn't reveal my whole background. I just stepped off 8 years on the Spokane Plan Commission, where we were part of the development code reform, which is just really something the whole city's proud of. But I'm also the vice chair of the State Building Code Council, and in that we thank the legislators for mandating now some code reform in the building codes and the fire codes and the residential code, where we're going to start to now see these single stair buildings, for example, up to 6 stories. And in that, it's just opening up this whole spectrum of things we're doing at the state level in the building, in the life safety codes, things we're doing in the local jurisdictions on the development codes, and things that manufacturers and architects and engineers are doing with this system approach of getting things certified as far as we can go in ICCS reports and so forth. That's all that testing out is showing. That's intent, is to get it into code reports so we can say to the building official, try to relieve them a lot of that alternative methods, alternative materials design and methods approach. So all of the above, but Seattle, Portland, our projects are in permit.
Totally, projects are in permit. When everyone's like, when's it available at scale? When you bring us 500 projects. when we have enough projects. And not that any one person's going to bring us 500 projects right now, but we're trying to get from a run of 9 or a run of 7 up to a run of 100. And that's when we start to see the cost efficiencies, even though we're making it pencil and performance today. Yeah. So scale takes all of us, I think, is my message there.
And then back to kind of that local code and the kind of building code requirement stuff. So if a local government wants to see more mass timber construction in their community, low-rise and mid-rise developments, are there common local rules and regulations that are most frequently in the way of that happening?
Not at the, well, you always, obviously in the state of Washington, like Oregon, we can't go to a statewide official to help relieve the jurisdictions in the life safety codes. But we are setting precedents, first of all. Obviously you set Seattle and Spokane. That's really important in the state to help other jurisdictions, smaller jurisdictions, have a precedent. But then, of course, on the development code, I think that's talked a lot in the last couple of days that, yes, let's get the zoning reform in line with our building codes. And it's a lot of what we talk about in Spokane is we're really proud, again, of being progressive in terms of the zoning development codes. Now we know we need to look at the building codes and align them and make them, and also do feasibility analysis along with those development codes. I have not found that the bigger jurisdictions have been resistant to this. Spokane Valley has been an outstanding partner as a smaller jurisdiction in being, not aggressive, but being progressive partners in understanding the problem so we can help even the larger jurisdictions relieve them of that nervousness.
Yeah, maybe Megan, you want to talk about how City of Seattle received Hartwood from a jurisdictional standpoint. I think in general our experience is it isn't taking longer with CLT jurisdictionally. There's regulation problems, there's prescriptive code that mandates bigger foundations, even though engineering-wise we wouldn't need them. So there's code problems, but it's at this moment everyone seems excited about it, and we haven't had major slowdowns about CLT. But that's on the low-rise side, so.
Well, I can say even on the high-rise side that the jurisdictions have not been hindering us in that way. So with getting Hartwood approved through the code, and doing it to the code, importantly, not asking for special exceptions, which a lot of tall timber buildings do. They use AMMRs, alternate means and methods, to prove their paths. We really wanted to focus on getting the code language interpreted by the city where there were sort of untested areas, because this code language is new, and we wanted to prove out a lot of those. So a lot of our work with the jurisdiction was getting those interpretations. So that 2-hour rated joint, we needed engineering judgments on the intumescent tape that we were using. And there were several in that area of just getting them to understand how to apply this new code language. And getting that done at least one time through the city means it's going to be easier for everyone else coming after us. And that's the hope, that this is sort of the first nudge in that scale.
Then there's a question about financing. Given that design and fabrication has to occur much earlier in the process than traditional stick frame construction, how must financing change to allow for this method of construction?
That is the key question all the time. It always comes down to money, so this is no different. I think Megan mentioned it a little bit. When we're doing prefabricated components, often there's a deposit that's much earlier in the cycle. The design part doesn't seem to be where the financing gets held up, at least on the scale of buildings that we're working on. That design budget's about the same. You're producing work, you're getting paid for it. Sometimes design fees are coming from a slightly different part of the capital stack than the construction financing itself. So the rub comes when we are trying to get to construction financing. You've got your building permits, you haven't paid for them yet. But if you really want to start that construction within like 1 month of mobilization, you needed to have put the deposit down on the mass timber from Mercer 2 months ago, 3 months ago, to save that spot. If you're doing modular assemblies, you're going to need to make sure you save, you are in the queue for that spot, and those items can be bought ahead of time because you want to go when it's time to go. This isn't completely new. This is modular and prefabrication that's been around for a long time. A few of us were remarking yesterday that 12 years ago, it felt like you were explaining to banks how it worked from the get-go, and now people get it. They're like, oh, you're doing prefab. Well, we have a hard time getting the deposit early. And you're like, cool, I'll find somebody else. Or they're like, oh yeah, we've done that before. So everyone's understanding because it's all about risk and securitizing, and can they call the CLT once the deposit's paid, collateral as if it were on site. So banks are getting hipper to it, but you do need to have that deposit cash available sooner.
And then talking about the timing, this is a little similar but different in terms of not the financing piece, but when you're thinking about at what point in design of a 200-unit multifamily development should a developer bring into the manufacturer? So kind of what you touched on.
The first part.
Yeah.
As soon as you were like, I think I should build something. I think one of the things that we've really noticed is we're trying to drive down the cost of all materials and all design processes. Is the sooner you're pulling together that integrated team, the better the solution's going to be. The better the lower cost you're going to find. I think one of the things that's been happening in mass timber, and Todd, you can agree or disagree with me about this, is like, people are designing these beautiful mass timber buildings, then you want to go take it out to bid across mass timber factories. But the panels aren't the same, the structural values aren't the same. It's kind of slowing down and gumming up the whole works. Whereas if you design your building to meet, if you can bring in that partner sooner, then you're going to optimize your design for the billets. You're going to optimize use of material, which is going to lower down cost. You're going to have to, but then how do we trust each other? Because that's, it's not capitalism to be like, well, Kalishnikov gave me a better bid. But if you can't use the panel or you have to redesign, what's the point? And the way that we kind of see our building system happening is that we partnered with Mercer as our initial partner. Our building system is designed around Mercer's panels. And in order to scale, we're going to have to onboard additional mass timber manufacturers so that we have a building system that meets those. This is part of the lack of single standard across mass timber panel sizes, and there's more and more standards coming for structural, performance. But in the meantime, we need to get stuff on the ground now. So it's all about, I think you have to, if you're going to be really efficient, you need to know who is providing those panels, and you need to know who's going to be assembling them first.
Yeah, absolutely right. And I'll just add one thing is that pick anybody. I guarantee you'll do better by just picking somebody and running with it. You're 2% savings by bidding. Now, projects, of course, a lot of projects you have to bid multiple, vendors and so forth. That's kind of not the takeaway here. What scares a manufacturer is, yes, you have to bring 30% down, but what about that other 70% that we're taking risk on? That's the part we all collectively have to de-risk, whether it's revolving loan funds or whatever else like that, especially on these affordable or other housing projects. No, I don't know the answer, but that's the part. Like, you think about a company like Mercer. I work for a public company. It's their holdings are in commodity pulp, and so that's they understand, like, a bunch of lumber sitting here, those are gold bars. Those have value, and that doesn't scare them. What scares them is when you start to transform them into something custom, and then that project fails, and we're sitting on 70% of the job, right? Just that's the pre-manufacturing problem. So anyone who can figure out that gap on who takes that risk, if it's not the working capital, who is putting that financing in until that's transacted at the site? That's the nut to crack, and we hope from the design side we're helping by making repeatable components and things, that if that project slows down, or dies or whatever, we're able to use that material in a different project. That townhome in Tacoma probably can be adapted pretty quickly for Portland.
So there was a question about costs back in your presentation. Were those price to build or price to consumer?
Price to build, all construction cost. And that we had some prices there on a couple of the units, so we've got hard numbers on. What we're finding for these 2-story, 2 or 3 bedroom, there's a flex age-in-place bedroom, is coming in, the construction budget, which includes project management and everything, is $278 a foot. We are doing side-by-side stick framed construction on that project. That stick frame is looking at $220 a foot. We're at really low numbers. There's obviously a gap there. I think the gap comes into like how much more awesome we think the CLT is going to be, how much more carbon negative. But it's also an amazing starting point. $278 in Seattle is what it costs to build. Portland's a little cheaper to build in. So we think we're right in range. And like I said, the N of just a handful. So where there's no scale there, that's like N of 1. It's more than 1. I think we're going to do 4 or something. But it's, and then the same number in stick. But it's like, how do we get that 278 to 220 is the gap we're working on now. Yeah, question.
Maybe a follow-up on that. Have you seen any difference in appraisals between the 2 product types?
That's a great question. The question was, are there any difference in appraisals between the 2 product types? And we think yes, especially we're using the hybrid system. So we're using that CLT cut into effectively CLT studs as the walls, and then a panel floor and ceiling. And so the ceiling is exposed in the units. And the way that appraisals work is it's feature forward, right? So that's the consumer market side. It doesn't look nicer than the things around it. And we have a professional appraiser as my co-founder, and we will be proving that out, but we're expecting a lift in the sales side.
What about insurance? Is there a change? Have you seen any difference in the insurance market? How's insurance playing out?
On the low-rise scale, especially in the townhouses and single-family homes, the cottages, no problem with insurance. It's a wood building replacing a wood building. I think we get into the insurance for mass timber in multifamily scenarios, and especially the taller you go. And for that, who wants to take it? Insurance? Insurance?
There's probably a whole other panel on that or something.
There is probably a panel on that. I know that there's a lot of people working on it. I know it's hot at Woodworks right now. I know it's hot for the U.S. Forest Service. Insurance of the mid-rise and tall buildings for the fire code. I mean, it's perception. The testing has been done, right? Everyone's like, oh, wood building, that's going to burn faster. But this is not a brand new building material. It's been in Europe for a long time. We've been working on it. Susan Jones has been working on it for a very long time. Todd, so we know that what the burn factor is, and we also know that you can tell how wood is doing structurally as it burns, unlike steel that all of a sudden breaks. So it's more just like the perception in probably some kind of like weird ancestral memory of the great fires in our DNA. I don't know.
If you do have actual insurance questions, we do have experts on our team, and we're trying to publish white papers, and it's just not me. So.
Go ahead, Beck. You fight through that one. I'm not.
And then, I'm trying to pick like one final question here. This is more of I think a systems question kind of. How do we get more large corporations like Amazon and Microsoft to adopt mass timber buildings in new construction? So maybe that's more of a philosophical debate.
I mean, they're doing it. I mean, Amazon and Microsoft are building mass timber buildings commercially. Google, they're talking about it for data centers. I don't know if anyone's built mass timber data centers yet. I don't think you're supposed to talk about it. It's always supposed to be secret. I think they're funding mass timber buildings with their housing funds and other things. So I think they have a lot more money. They could be doing more. So that's facts. But and also the Department of Defense is pushing. I mean, the Department of Defense new construction every year is $500 billion. It's like the same as the whole housing industry in the U.S. And they're pushing for all new construction mass timber in the next farm bill. Like, if they do that, that's going to drive a huge amount of mass timber. We can't possibly provide that. So it could really be a market driver. And I think the reason for that, and just to not say much, but Department of Defense is all about sustainability and resilience, which is actually like some of our best sustainability in vehicles and buildings and airplanes comes out of DoD. Little known fact. Yeah. We are going to be at our module at Mercer Mass Timber. If you want to walk through our house and take a look at it, please come up and see us, and we'll make sure we can find a time. Any last words?
Thank you. Thank you.
Thank you so much. We'll be here for a few minutes.